Sometimes the biggest, most universe-altering stories come in the absolute tiniest packages. We're about to dive into the incredible journey of a single grain of rock, literally just a few millimeters across, that holds a secret about the violent birth of our solar system. A secret that sends scientists on this wild, decades-long chase all across the globe.
And it all kicked off back in 2009 with a pretty frantic email. The subject line was just 3 words: help, help, help. It came from a physicist named Paul Steinhardt, and he sent it to a geologist he'd never even met, Lincoln Hollister. See, Steinhardt had this impossible rock on his hands, and he had no idea where it came from. And that one email, it kicked off one of the greatest scientific detective stories of our time.
And this is our main character. It was found in the basement of a geology museum in Florence, Italy. Just a tiny, dense little grain of rock that honestly looked completely unremarkable. But locked inside was a mystery that was about to challenge our entire understanding of how matter can even arrange itself.
When geologist Lincoln Hollister first got a look at it, he was not buying it. Not at all. To him, this mishmash of metal and mineral looked like slag. The leftover gunk from a metal factory. He'd seen tons of weird rocks that people had picked up near old iron furnaces, and this one felt just like another piece of industrial junk.
The real puzzle, the thing that made it feel so unnatural, was that it had both metallic aluminum and copper stuck together. And that combo, it just almost never happens in nature. See, aluminum likes to bond with oxygen, and it resists water. Copper, on the other hand, bonds with sulfur and dissolves in water. As Hollister said, man can put these elements together, but nature takes them apart. This thing just felt wrong. So, right as the team was about to just give up and call it a day, they found their first big break. Buried inside the rock, right around all the weirdest parts, was a mineral called stishovite. And let me tell you, this one little mineral changed everything. Okay, so stishovite is this super high-pressure version of quartz, and it can only be created in one of 2 ways, either deep, deep inside the Earth's mantle or during a really violent high-speed impact out in space. So right away, that whole factory junk idea, out the window. This rock had an extraordinary and very, very natural story to tell.
But believe it or not, the rock's origin wasn't even its biggest secret. Nope. Inside, it was hiding a type of matter that, for decades, science had considered completely and utterly impossible.
All right, so first, a quick refresher. A normal crystal, whether it's a snowflake or a diamond, is all about repetition. The atoms are arranged in a pattern that just repeats perfectly, over and over and over again. You can think of it like a kind of cosmic wallpaper. But what these scientists found inside this little rock was a quasicrystal. It has perfect order, but its atomic pattern never repeats itself. The scientist who first discovered these things in a lab, a guy named Dan Sheckman, was basically laughed out of the room for years before his work finally won a Nobel Prize. And this meteorite, it had the very first one ever found in nature. And just look at this. This is the atomic pattern of the quasicrystals, and it really shows you just how bizarre this thing is. You can see it has what's called 5-fold symmetry, a pattern that is physically forbidden in a normal repeating crystal. It's beautiful, it's perfect, and it was supposed to be impossible.
For Paul Steinhardt, the physicist who sent that frantic email, this was the moment of a lifetime. He had been hunting for a natural quasicrystal for more than 10 years. Finding this proved they weren't just some weird thing you could cook up in a lab. They were a stable, natural state of matter that could survive for billions of years.
Okay, so they proved the rock was a meteorite, and an impossible one at that. But that was just the beginning. Now they had a much bigger problem. Where in the entire universe did this thing actually come from? And, more importantly, could they find more of it?
But yeah, there was a problem. After years of poking and prodding and analyzing, their one-of-a-kind sample had been basically turned into dust. To really understand its story, they had to find more. They had to trace this tiny rock from a museum basement all the way back to its source. The hunt was on.
And man, what a hunt it was. The trail was ice cold. It started at the Florence Museum, led them to a Dutch collector whose secret diary pointed them to a dead end in Romania. But then, get this, a secret diary revealed the rock actually came from a Russian platinum expert who had no memory of where he got it. Finally, a tiny footnote in a 1985 research paper led them to the original finder, a Russian mineralogist named Valery Kryako, who had panned these strange little nuggets from a remote stream all the way back in 1979. And here's the crazy part. Chukotka remembered the exact spot. So, the team started preparing for an expedition to one of the most remote places on planet Earth, all to search for more tiny grains of this impossible meteorite.
So in 2011, they traveled to Chukotka, Russia, a region so sparsely populated it actually has fewer people per square mile than the Sahara Desert. They used these rugged snowcat vehicles to cross hundreds of miles of thawing tundra, heading for a tiny stream called the Listvenitavi, with the very man who first found the rock over 30 years earlier leading the way. The whole expedition was just this frantic race against the clock. Over 10 days, the team panned 1.5 tons of icy, miserable clay. From all that, they found a few kilograms of promising grains, and from that, they managed to identify 9 new fragments of the meteorite. They packed up and got out of there literally one day before the harsh Arctic winter slammed the door and snowed everything in.
The team had done it. They succeeded beyond their wildest dreams. But when they got the new samples back to the lab, the story took another, even more shocking twist. It turns out this little rock wasn't quite done revealing its secrets. Tucked away inside these new meteorite fragments was yet another mineral that simply shouldn't have been there, ringwoodite. And this discovery, it was about to rewrite the entire history of this incredible rock all over again.
Ringwoodite only forms under unbelievable, mind-bending shock. We're talking pressure that is more than 5 million times the atmospheric pressure here on Earth. That's the kind of cataclysmic jolt that might have formed our moon. Now here's why that was so stunning. The meteorite was identified as a carbonaceous chondrite. That's one of the oldest, most primitive types of rock in the whole solar system, basically a fossil from its very birth. And these meteorites, we've always believed they formed peacefully, just by slowly clumping together. As Hollister put it, you just don't find this type of meteorite with evidence of such an extreme shock. It was unheard of. This one discovery revealed a brand new, incredibly violent timeline. It means that 4.5 billion years ago, as our solar system was just a swirling cloud of gas and dust, these chemically incompatible elements, like aluminum and copper, somehow got smashed together. They got embedded in an asteroid, and then that asteroid was part of a cataclysmic high-speed collision that generated enough shock to form ringwoodite. It suggests the early solar system was a far more violent place than we ever knew.
And that really brings us to where we are now. After this whole decade-long journey, the quasicrystal is actually no longer the biggest mystery. Scientists now accept it's a stable, natural form of matter. The real puzzle, the one this little rock has left us with, is how in the world those impossible aluminum-copper alloys managed to form in the chaos of the early solar nebula in the first place. This whole incredible story, from a desperate email to a treasure map and a secret diary to a perilous Arctic expedition, all of it came from a single piece of rock smaller than your fingernail. It really makes you wonder, doesn't it? What other profound secrets about the birth of our own world are out there, just lying hidden in a single, forgotten grain of dust?